Welcome back. Welcome back to Learning Here with me at MPB. I am Ms. Killen. We are in our Unit 7 lessons, working with our quadratic functions, and today we are looking at transformation of the dependent variable of the quadratic functions. Remember that dependent variable is independent variables that we've learned. I can apply vertical shifts, reflections, stretching, and compressing to a quadratic function. We are looking at FBF3. So let's go ahead and dive on into this. First thing, we need to remember some vocabulary. So let's look at this vocabulary. Independent variables. What are independent variables? Independent meaning they don't have to worry about anybody else. So here is my independent variable. And what about my dependent variable? We said that our dependent variable has to wait on something. So my dependent variable is my y values. And when you transform an equation with an independent variable, you're going to do some type of adding and subtracting. So now let's look when we transform the dependent variable, our y values. Remember, we are adding or subtracting outside of that parentheses, or we are multiplying to that f of x either with a whole number or we are multiplying with a fraction. Remember, when we're adding, we're transforming up, or we are shifting up, we are translating up. When I'm subtracting outside of that parentheses, I am translating down. When I am multiplying that function by a whole number that is larger than 1, I am doing a vertical stretch. And we need to make sure that we are putting these on those notes pages. And then when I'm multiplying by that fraction, like right there, this is when I do that vertical compression. All right, so one thing that I want us to make sure that we are getting is when I'm doing that stretch, it's getting skinny. Think about when I have a rubber band and you're holding your rubber band and you pull it, it's getting really, really thin. Now think about that same rubber band and I compress it, it's getting really, really wide. So when I'm vertical stretch, I'm getting skinny, and when I'm doing that vertical compression, this is when it gets wide. So we need to make sure that we're putting these on our notes page. I want us to make sure that we got those. All right? So let's try some transformations. So here we go. Let's look at these. So I have f of x equals 4. I have g of x equals f of x plus 2. h of x equals f of x minus 2. Now, what I need us to see is that this right here would be our parent function, so to speak. So then when I take and I'm going to find my g of x, so let's look at this. I'm going to take right here where it says f of x and put a 4 and then have that plus 2. So my g of x, if we're looking at our notes page or at my screen, we're saying that g of x is that number 6. Awesome. Now, let's look at h of x. Look at it on your paper or look at it on my screen. I hope you can see this. I have my h of x equals f of x, which is 4, minus 2. So when I have that h of x equals 4 minus 2, I'm going to have h of x equals 2. So you need to make sure that you can see these calculations of how we're using that quote, quote, parent function to get these new functions. All right? So let's look at another problem like this. So if we have these functions, and here's 3 new functions, and we're using x equals negative 2. We're going to use that parent function to find these 2. So everybody up here, look at my screen, and let's work these. So I'm looking at g of x equals f of x equals negative 2 plus 2. So when I have negative 2 plus 2, my g of x is going to equal 0. Make sure that you are looking at my calculations, how I'm plugging this number in to get this new function. So now let's do h of x. I hope everybody can see this. H of x equals f of x is negative 2, and now I'm subtracting 2 from that. So what I've got is negative 2 minus 2, so my h of x now equals a negative 4. We took our parent function, we plugged that parent function into our new and found what that g of x and that h of x was going to equal. Awesome. So let's look at some more problems. Let's do some practice. Now, look at the table and complete by using information we have learned. Decide what happens when you multiply f of x by a constant. All right, so let's look at this. So I have x and I have what my x is equal. I have my f of x and what my f of x equals. And then it goes into telling me what they want us to do. Now, I'm going to work this up here, and I want you to work at your table. Once you finish working, look back up here and see what I did. I want everybody to be able to see what I've done and how I got these calculations. Because the math works if you know where to put this f of x and what to use for this f of x. So here we go. Let's look. So the first one I'm going to look at is my h of x. So my h of x is, h of x equals 2 times f of x. My f of x is 4, so 2 times 4, so my h of x is going to equal 8. Then I have j of x. J of x equals 1/2 f of x. F of x is my 4. So 1/2 times 4 is going to give me j of x equals 2. Then I have my m of x. My m of x is a negative of my f of x. And we said that my f of x is 4. So my m of x will equal a negative 4. So I took what we were doing to those f of x and just put that number in. So let's go to the next one. The next one we're going to use is when f of x equals 1. Same problems, we're just now putting 1 for that f of x. So I've got 2 times 1, and my h of x equals 1. No, excuse me, my h of x equals 2. Next one, I have 1/2 times 1, so my j of x is going to equal that 1/2. My m of x is taking my f of x and making it negative, so I'm going to have my m of x equals negative 1. All we're doing is taking whichever the f of x that we are at and plugging it into, kind of like substituting a number in to my variable. So let's do the next one. Miss Killenwright's a little sloppy, so she's going to show you where we're starting on our 0. So this one I'm doing 2 times 0, so my new h of x would equal 0, because anything times 0 is 0. The next one for j of x, 1/2 times 0, so my new j of x would equal 0. Now my m of x, anything times 0, 0. So that negative, which has a understood 1 behind it, is still going to be m of x equals 0. Good job. Now, I want you and your lab partner, or just you by yourself, to do the last 2 f of x, the positive 1 and the 4. Plug those in and see what you get. All right, so does your table look like my table? For my h of x, I have 8, 2, 0, 2, 8. Notice it looks like a parabola. For my new j of x, I have 2, 1/2, 0, 1/2, and 2. Also looks like a parabola. And then my m of h is negative 4, negative 1, 0, negative 1, and negative 4. So that's how we take that f of h, plug it with some type of operation to get yet a new variable value. All right, now that we have our graph, let's sketch this out. Now my parent function is right here. So this is going to be my parent function. We're going to call this my parent function. We're going to put it in red. So then let's go ahead and do my h of x. So I have my x values and my y values. -2, 8. You may have to put some more up here. So -2, 1, 2, 3, 4, 5, 6, 7, 8 is going to be about right there. Then I have -1, 2, -1, 2. I have 0, 0, going to be right there. I have 1, 2, +1, +2, 2, and +8. So here is, let's pretend Miss Killen can draw straight. So this is my h of x. Now, when I compare it to that parent function, what do you notice from my red parabola to my black parabola? Exactly right. It looks like it's stretched. It's gotten skinnier. So now let's look at j of x and see what we do there. So let's get another color, and let's do green. Okay, so I still have my x values here, and I'm going to use my y values. So -2, +2. So I have -2, and then here's +2. Then I have -1 1/2. So -1 1/2 goes about right. Nope, it's not going to be there either. Whoops. Okay, so I got this one, -1 and about right there. All right, so then I have 0, 0, obviously. I have +1 1/2, +1 1/2, and then 2 and 2, so I have 2 and 2. So let's graph this. So let me go back and put our red one there so we can compare them. So what could you say goes for the green one? It almost looks like it is getting a little bit skinnier than the red one, but it's not as skinny as our black one. So we could say it's slightly skinnier. So let's just put j of x here. And then let's do our last one. And let's get purple. So here we go. So I have -2, -4. -2, whoa, Miss Killen, we're going the opposite way. 1, 2, 3, 4. Here we go. Then I have -1, -1, 0, 0, 1, -1, and then I have 2, -4. Well, what in the world happened when we went from our parent function to the purple function? It reflected. So this one is going to be a reflection. That's when we kind of use that x-axis as a mirror, and what it looks like on one side is going to look like it on the other side, but opposite. So how we're opening up for the parent, we're opening down for the transformation. Good job, guys. Now it's time for you to master. If we are given the function f of t equals y squared, which should be t squared, excuse me, plus 3, identify the effects on the graph of f of t with the following. All right, so we have f of t plus k where k is greater than 0, f of t plus k where k is less than 0, k times f of t where k is greater than 1, and then k times f of t where k equals a -1. So go ahead and pause the video. You work with your partner or by yourself, and then come back and let's see what we can do. All right, so we've got these 1, 2, 3, 4 effects that we're looking at. So when I see f of t plus k, where k is greater than 0, I am looking at some type of shift of my f of x, and I'm going up k units. All right, the next one, f of t plus k where k is less than 0, meaning it's going to be a negative, I'm going to have a shift of f of x, and I'm going to shift down k units. Now I'm multiplying k to my f of t where k is greater than 1. So this is what we're going to call a vertical stretch. And then it's going to be by a factor of k units. And then we have k being multiplied to f of t where k equals a negative 1. So since it's a negative 1, it's going to be a reflect my f of x, excuse me, my f of t. That should be f of t, guys, my bad. And that's going to be a reflection of that f of t about the x-axis. Y'all make sure that you put in your t's. Miss Killen is so used to putting those f of x, she just put that by mistake. So when we have that negative 1 being multiplied, we need to make sure that we're understanding that it's going to be a reflection. It's always going to be a reflection when it's that negative. All right? So let's look at this. We don't want to forget how k is going to affect our independent variable. It's going to go up if it's adding, down if it's subtracting. Our positive number to our f of x that's more than 0 is going to be a vertical stretch. That is 0 is less than k, which is less than 1. That's going to be a compression. We need to make sure that we remember those. I'm so glad that you came here to learn with us here at MPB. I've had a great time learning with you. Thank you and have a great day.